Hello and welcome back. Today we're talking about an accelerated geometry / algebra 2 lesson, and the topic is rational root theorem. We're going to be talking about how to find all of the zeros of a polynomial equation. So the first step would be to, if possible, factor the polynomial. Number two, if you can't factor, then you're going to list all of the possible zeros using the P over Q ratio, and then you're going to be testing those zeros until you find one that works. Or you can use your graphing calculator and look at the picture of the graph and then find all of the zeros that you can see from the graph. Once you find the ones that you can see from the graph, you will then use synthetic division to reduce the polynomial. In step 4, if possible, you're going to factor or use the quadratic formula to solve for x. If you can't factor or solve for x, then you can use another zero from your calculator and then use synthetic division to reduce the polynomial further. And number 5, you will factor or use the quadratic formula to solve for all of your zeros. All right, let's get started with example 1. We're going to find all the zeros. In looking at example 1, I notice that I can probably factor by grouping. I'm looking at the coefficient of x cubed and the coefficient of x squared. That's 1 to -1. Now I'm also looking at these last two coefficients. That's 49 to -49. Well, that reduces to 1 to -1. So in the first group, the ratio is 1 to -1, and in the second group, we also have 49 to -49, which is 1 to -1. So that lets me know that factor by grouping is going to work. So we group the first two together and the last two together. The greatest common factor in this first group is going to be x squared, and the greatest common factor in the second group is going to be 49. So we factor out the x squared from the first group, leaving us with x minus 1, and factoring out the 49 from the second group also leaves us with x minus 1. Now, of course, we have x minus 1 that is common in this polynomial. So if we factor out the x minus 1, we have x squared plus 49 left over in the second group. Now we need to set each one of those equal to 0 and solve. So if x minus 1 is equal to 0, then we know that x will equal 1. So that's one of the zeros. Now let's set x squared plus 49 to equal 0. We can subtract 49 from both sides, and then let's take the square root of both sides. So x would be the square root of -49 with a plus or minus in front. And we know that the square root of -49 is 7i. So we have x is equal to positive or negative 7i. And we have all three of our zeros. So our zeros will be positive 1, from the x equals 1 here, and then -7i and positive 7i. Notice that only one of these zeros is real, and two of them are imaginary. All right, here's example 2. We have our polynomial here, and we have the accompanying graph on the right. When you're looking at the graph, you want to find places where the graph crosses the x-axis, and we can see that it crosses the x-axis at -4. It also crosses the axis somewhere between -2 and -1, but we don't know exactly where that is, so we don't want to guess at that one. Likewise, if we zoom in a little closer here, we can see that it's crossing here close to 2, but not exactly at 2. So we're not going to use that one either, so let's just use the one that we know, which is crossing at -4. All right, so then we will use the synthetic substitution or synthetic division to complete this process. So we have negative 4 on the outside, and these are our coefficients. And you know the process. We're going to drop down the 2, and then we're just going to multiply and add the rest of the way. So we have 2 times negative 2 is going to be negative 8. Negative 8 plus 7 is negative 1. Negative 1 times negative 4 is positive 4. Negative 9 plus 4 is going to be negative 5. Negative 5 times negative 4 is positive 20. And negative 20 plus 20 is going to be 0. So now we have verified that negative 4 is a 0. The resulting polynomial from these coefficients is 2x squared minus 1x minus 5. Now, if you multiplied the 2 times the negative 5 in process to try to factor this by grouping, you'd get negative 10. So 2 times negative 5 is negative 10. Then we would look for two numbers that would multiply to negative 10, but that would also add up to negative 1. And there are no such numbers. There are no two numbers that would multiply to negative 10 and add up to negative 1. So therefore, we cannot factor this. The next step would be to solve by the quadratic formula. So let's do that. Plugging the numbers into the quadratic formula, that's the negative of the b value plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And that simplifies to positive 1 plus or minus the square root of 1 plus 40, all divided by 4, which then simplifies to 1 plus or minus the square root of 41, all divided by 4. So we have our 3 zeros. We have the 0 from the negative 4 that we got from the graph. And then we have 2 zeros coming from this expression, 1 plus or minus the square root of 41 over 4. So one of those solutions would be 1 minus the square root of 41, all divided by 4, which is approximately negative 1.35. And that would be the 0 that's right here in between negative 2 and negative 1. And the other 0 is 1 plus the square root of 41, all divided by 4, which is approximately 1.85. And that is the 0 that is really close to positive 2. All right, so once again, our zeros are negative 4, 1 minus the square root of 41 over 4, and 1 plus the square root of 41 over 4. All right, moving on to example 3. Here is our polynomial, and I just entered this polynomial into my graphing calculator, and this is the picture of what the graphing calculator shows. As you can see, there are 2 zeros that are shown here. I'm going to go with the 0 on the left, and that is at negative 5. So we're going to verify that negative 5 is a 0 by using synthetic division. So we put negative 5 on the outside along with our coefficients. Dropping the 1 down, multiplying 1 times negative 5. We get negative 5, add negative 5 and 6. That gives us positive 1. 1 times negative 5 is negative 5. 14 minus 5 is 9. 9 times negative 5 is negative 45. 54 minus 45 is 9. And 9 times negative 5 is negative 45. And 45 minus 45 does give us 0. The resulting polynomial is x cubed plus x squared plus 9x plus 9. And we're going to factor this by grouping. I recognize that because the coefficients in the first group is 1 and 1. And the coefficients in the second group is 9 and 9, which reduces to 1 and 1. So we can factor this by grouping. Factoring out the x squared from the first group gives us x plus 1 in parentheses, and factoring out the 9 in the second group gives us x plus 1 in parentheses. And then the x plus 1's are common, so factoring that out we get x plus 1 times x squared plus 9. And then we set x plus 1 equal to 0, and we get x equals negative 1. So negative 1 is going to be one of the zeros. And then we also set x squared plus 9 to equal 0. Let's subtract 9 from both sides, and then let's take the square root of both sides. So x would be plus or minus the square root of negative 9, which becomes plus or minus 3i. So we pick up 2 more zeros there. So we have a total of 4 zeros. The zeros are the negative 5 that was shown from the graph, the negative 1 that is picked up here, and then the other 2 zeros are negative 3i and positive 3i. All right, here's example 4. We have this polynomial, and putting that into the graphing calculator produces this graph. From the graph, we see that one of the zeros is positive 4, and that's the one I'm choosing to work with. So let's verify that 4 is a 0 using the synthetic process. 4 goes on the outside, and here are the coefficients. Dropping the 3 down, and then multiplying 3 times 4, we get 12. Negative 13 plus 12 is going to be negative 1. Negative 1 times 4 is negative 4, and 2 minus 4 is negative 2. Negative 2 times 4 is negative 8, and 8 minus 8 is 0. So we verified that 4 is a 0. The resulting polynomial would be 3x squared minus 1x minus 2, and let's see if we can factor it. To factor it, we will multiply the 3 times the negative 2. That's going to give us negative 6. Now we're trying to find two numbers that would multiply to negative 6, but would also add up to the negative 1 in the middle. Those two numbers would be negative 3 and positive 2. So we can factor by grouping. So we have 3x squared minus 3x plus 2x minus 2. And grouping the first two and the last two together, the common factor in this first group would be 3x. And what's common in the second group would be 2. So we have 3x times x minus 1 plus 2 times x minus 1. The common factor here would be the x minus 1's. So we have x minus 1 times 3x plus 2, and we'll set those equal to 0. When you solve the x minus 1 equals 0, you get positive 1. And when you solve the 3x plus 2 equals 0, you would get a fraction, and that would be negative 2/3. So we end up with 3 zeros, and they are the 4 from the graph, 1 from the x equals 1 here, and negative 2/3 from here. All right, example 5. In this polynomial, I'm recognizing that we can solve this by grouping. The coefficients of the first two terms are 2 and negative 1. So that ratio is 2 to negative 1. The ratio of the second group is we've got negative 32 and 16. Well, if you divide those two, that's also in a ratio of negative 2 to 1. So let's factor by grouping. We group the first two together and the last two together. The common factor in this first group is going to be x squared, and the common factor in the second group is going to be negative 16. Factoring out the x squared, we get 2x minus 1 left over, And then factoring out negative 16 from this group gives us 2x minus 1. So now 2x minus 1 is common, and we can factor that out, and we get 2x minus 1 times the x squared minus 16. We'll simply set each one of these equal to 0. So if 2x minus 1 is equal to 0, then x is going to be positive 1/2. Likewise, if we set x squared minus 16 to equal 0, we could add 16 to both sides, and we'll have x squared equals 16. Taking the square root, we get x equals plus or minus the square root of 16, which is plus or minus 4. So we have 3 zeros. They are the 1/2 from here, and then negative 4 and positive 4. And there we have them. Our 3 zeros are 1/2, negative 4, and positive 4. All right, we're going to finish up with example 6, and then you guys can do examples 7 and 8 for homework or classwork. So here's example 6. We have this polynomial. Putting that into the graphing calculator produces this graph, and we can see that it crosses the x-axis at 2. So we're going to use 2 as our 0. So we put 2 on the outside, and we have the coefficients here. We're dropping down the 1 and multiplying. 1 times 2 is 2. 4 plus 2 is 6. 6 times 2 is going to be 12. Negative 6 plus 12 is 6. 6 times 2 is 12. And negative 12 plus 12 is a remainder of 0. So we verified that 2 is a 0. The resulting polynomial will be x squared plus 6x plus 6. If we set that equal to 0, now we could test it to see if we can factor, but you'll see very quickly that you cannot factor this because we cannot find two numbers that would multiply to 6 and also add up to 6. So the options are to solve by the quadratic formula, but I want to remind you of another method. And this other method is by completing the square. So just for fun or just for a reminder, let's do completing the square. What you'll do is you'll subtract 6 from both sides and add the 2 blank spaces here. We then take half of the b value, so half of 6 is 3, and then we square that. So 3 squared would be 9, so we'll add 9 to both sides. We can then factor the left side. That's going to be x plus 3 times x plus 3. We'll add negative 6 plus the 9 on the right, giving us positive 3, and that's equal to x plus 3 all squared. We'll then take the square root of both sides. So we get x plus 3 is equal to plus or minus the square root of 3. We'll then subtract 3 from both sides to isolate the x. So x is negative 3 plus or minus the square root of 3. Now we can write our zeros. The zeros are going to be the 2 that we got from the graph and that we verified here synthetically, and then the 2 radical zeros. That's negative 3 minus the square root of 3, which is approximately negative 4.73. And that would be the 0 on the far left over here on the graph. And we have negative 3 plus the square root of 3, which as a decimal is negative 1.27. And that would be the 0 here. All right, so again, these are our 3 zeros. All right, that concludes our lesson on the rational root theorem and finding all of the zeros.